Let's begin some practice on actually getting into the application of dimensional analysis. So the concept that we're showing over here, in which we are going to solve a problem using firstly identifying the given unit and then need to know what the plan should be, that is, which needed unit to be converted to. For example, a person has a height of 2 meters. What is the height in inches? So what is the given information here? It's a word problem in which we know that it's 2 meters, and we're given meters, and we have to convert into what is the information that it's asking is that it needs to be converted into inches. So once you know what you're beginning with and what is your answer should be, my next question is, how many units do we have? Now, what is the equality between the two? So you need to know the equality, that is, 1 meter has 39.4 inches. So this would be an equality that we will talk about. Now, once you have this equality, we can actually, I'm going to go back and finish this problem. I thought I had it solved in the next slide. So once we have that, we can now see that the setting should be that you should have 2 meters times, you will now look at that equality and find out, I have meters over here, so my meters should be on the bottom, 1 meter, and I should have the top part as inches. So this would be your setup. And in this setup, once your meters and meters cancel, you just multiply 2 to the value of 39.4 and express your answer using one significant digit. Okay, so let's go on to the next problem. In the next problem, we have a problem in which it states an injured person loses 0.3 pints of blood. How many milliliters of blood would that be? So what is my given value? I have given is 0.3 pint. And what do I have to know? I have to know in milliliters. So you have to know, every time you try to do a problem, you should know where to begin and how to end. So these are the 4 main steps that I say to know. Always have your given and needed units. Always write your unit plan to convert your units, and then find out the equalities to convert, and then use a conversion factor. Now, the reason we're saying a plan is, for example, you can have something that, for example, it says yard, and you have to convert that into, let's say, centimeters. And if you didn't know exactly the direct relationship, one of the ways that you can say to do that would be to convert my yard to, let's say, my feet. And from feet, I can convert into inches. And from inches, I could go into centimeters. Another student can say, well, I know the direct relationship between yard and centimeters, so I can do it in one step. That is perfectly okay. And a third student would say, I can convert my yard to feet, and I don't need to go into inches. I know exactly how many centimeters are in a feet. So this is called as a unit, as a plan, as how are you going to follow through. And each person can have their own unit plan, and it doesn't matter if you don't coincide the same plan. The important thing is at the end you will have the same answer. So let's look at a very simple example first, in which there is a time problem in which we say how many minutes are in 2.5 hours. Our given value is 2.5 hours. We need to convert those into minutes. So my plan is directly hours to minutes. I start off with my 2.5 hours. My conversion factor, notice I've got my hours, canceling my hours over here to report my answer, and I'm reporting my answer as 2 significant figures over here. Now the reason for that is, and you might be saying, why do we have that as 2 when we have a value of 1, is whenever you have your conversion factor, then your conversion factor is equal to 1. So you almost need to ignore that value. So what I would say is the best thing to remember, and this is you base your value on the starting or the given unit. Because earlier I was showing you how to do multiplication and division without the units of conversion. But once you apply conversion factor, then your reported answer, just make it simple by reporting it in the given unit that you have. And you'll have less of a problem when you're doing your problems. For example, on the web study quizzes or in class or for quizzes. So here is an example of another solved problem in which we say a rattlesnake is 2.44 meters long. How many centimeters long is the snake? Notice my given plan is 2.44 meters, and my conversion is going to be an equality that will show me a relationship between meters and centimeters, and that is 100 centimeters equals a meter. And once I know that, always go with the unit that you begin with to put it down on the denominators, because these should cancel. My cancel buttons the slashes have moved, and now we have converted 100 to 2.44, and that is my needed unit. Again, notice 3 significant digits over here and 3 significant digits over here. That is, my reported answer should be in the one that is given. Probably would be the easier way to report your answers. Now let's look at some conversions in which we have 2 conversion steps. I gave you an example earlier with that, but let's just go into it. You can convert one unit to the intermediate unit and then to the last unit. So given unit, convert it into the second unit and then to the third unit. So let's see an example where we apply that. For example, we have 1.4 day and we want to convert that into hours. So first we'll have to plan our plan of attack, as I call it, day to hours, and then from day to hours, and from hours to minutes. Well, actually, this is what are we trying to do is we're trying to convert that into minutes. But over here, what we're saying is, why is the setup wrong? The setup you can see is wrong is because you cannot cancel in this manner. You will, if your units don't cancel properly, you are going to get an incorrect answer that you can see over here, because it's saying day squared times minute, and that's not exactly what we want. So what should be the correct way of doing it should have been 1.4 day should be converted into hours first. So you should have day on the bottom, 24 hours on the top. Actually, this was also incorrect. And then we should have hours are over here. So I'm going to have hours over here, and then my minutes over here. So my plan is always you take this value, you put it over here. So it should set up in this manner. You cannot do this way. You have to do slashes, or, backward slash, as we call it in the computer terminology. Okay, so let's see an example that is solved in which we are going to see 165 pounds converted to kilograms. Notice my given is 165 pounds. I need kilograms. So my plan is going to be an equality between kilograms and pounds. These are the 2 conversion factors. So now I can set my problem up, 165 pound, and I have my equality. My pounds are canceling, and I can express my answer with 3 significant digits, as that's what the answer is given, the quantity is given. Here is another example in which we are converting 4.65 liters of water into gallons. Now, this is one that I sort of like because it's got 2 steps to it. So you can't convert directly from liters to gallon. You have to convert liters to quarts first, and from quarts to gallon. So we need 2 different equalities. We need an equality that gives us 1.06 quarts to liters and a gallon to quarts. Where are these equalities coming from? This equality is coming from the table that I showed you earlier that you have to know. Most of the equalities in the problems that we will do for this class are going to be equalities that are in your book. Some of the problems, if you do in the class or in homework, you may have to look at the inside book of the book cover. That also has a table of all these equalities. So now let's look at the problem. Here is the liters, that is my given, which is 4.65, and I set up my problem. Notice I needed the first equality because it converts my liters to quarts, and now which one do I put on the bottom? I put down what is the given. Always remember the forward slash. And now we have quarts on the top. Again, we do the forward slash here. So you have gallons on the bottom. Do you see what I'm trying to show you is a one-step process? We did not complete the step here and wrote it down, and then we went on to the next step. We did a one-step process in which we are trying to solve a problem using this one-line statement. This is a very important step that I want you to be applying in your coming chapters as well. So I don't really care if you already know how to apply them, how to solve for this in any other way besides the one that I'm showing you. You must follow this pattern. I get students who are very, very smart, and they're in calculus classes, and they will say, well, we can just do it randomly on a calculator and we know our answer. Very good if you can do that. But still, I want to see this way. On your problems, on your exam, you will have a couple of problems in which you'll have to show the setups. So the setup is very important for you to apply. Here is another example in which we say a 3 feet pole is in length, and we want to convert that into millimeters. So again, feet have to be converted. My plan is to convert my feet into inches, my inches into centimeters, my centimeters to my millimeters. So this is the given plan. So you almost always must have a given plan before you can apply the equality and the conversion factors. So we have our feet. Notice from my inches, I come up with the equality of 1 foot equals 12 inches, and then I convert that into this conversion factor. Simultaneously, I've done the same thing on the second step and on the third step. Each time I'm trying to cancel in this manner. Very important. Not that I love making lines on this chart. I want to emphasize how should you be thinking about the process. Once you get all of this set up right, the multiplication and division is fairly simple, but I'm going to go ahead because sometimes students do ask me this question. You just have to multiply 3 times 12 times 2.5 to come up with your answer. But since your given value is 2 significant digits, you would report your answer with 2 significant digits. So the rest is just common multiplication and division that you should have done in at least Math 82. Let's see, I need to move this slide over here. Now, okay, I need to move it on the top. If your pace on a treadmill is 65 meters per minute, how many minutes will it take for you to walk a distance of 7,500 feet? Now, this is a long one. So let's think it over. What are we trying to do over here? We are actually, we have a statement that is 65 meters per minute. So this has to be expressed as a conversion factor. So that is a statement that can be written down. So we have 65 meters over a minute. So this is a conversion factor that I came up with a statement. Now I need to find out how many minutes will it take for me to walk a distance of 7,500 feet. So now, firstly, I have 7,500 feet, but my final statement is in meters. So the best approach would be for me to convert my feet to my meters first. So notice over here, I've done that in 4 steps. My feet into inches, inches into centimeters, centimeters into meters. And once I have that, I can apply the word problem. Now, a lot of times you will find problems like this that are in the book too, and I strongly suggest for you to practice on these that have the wording in them in which you have to express the wording into a conversion factor. The best way to solve these is to apply this at the end. So do all your conversion and use this scenario to convert. In other words, if you were to convert your 65 meters into feet and then do it, it sort of sometimes messes up your plan of attack. So the best thing is to convert my feet to my inches, to centimeters, to meters, and then finally put down the word conversion at the end. And that is the best way to solve problems which have statements like these, or there's an example in the book about the avocado one. Try doing that problem to master this concept. Oh, this is a slide we haven't done this. This is similar to the one we did before. Here we have if the thickness of the skin is 11% body fat, how much fat is in a person with a mass of 80 kilograms? So what we're saying is we have this terminology of 11% body fat, converted that into a factor, and then we start with 86 kilograms to solve for this. Now, I spent most of the time showing you how to set them up. I'm not really going to go into the math part because you just need a calculator to get out, in which you can simply take let's get rid of this box first, in which you can just simply take 86 kilograms. You just take the value of 86 times 11, multiply that and divide it by just do 86 times 11, divide that by 100 to come up with your answer. I'm not doing those in this lectures because I think that should be done on a calculator, and you can do those to solve and see if you come up with the same values. Here is another example that we want to practice, in which we have how many pounds of sugar in 120 grams of a candy if the candy is 25% by mass sugar. Again, whenever I have a word statement like this, it's best to apply that at the end. So 25% by mass sugar means that it's 25 pounds sugar in 100 pounds of candy. So once we have set this factor over here, I need to now convert my grams to my pounds of candy. So a gram has how many pounds? A pound has 454 grams. So I set up my grams here. Notice my grams are going in the bottom to cancel these, so that I can convert my grams to my pounds, and then apply the worded part of this problem, which is used as a conversion factor. Okay, so these are all the problems that we just did. We're going to conclude here, and I hope you practice a lot when you're doing it at home, and practice some of the problems, and then we'll do some more in class. Very essential for you to master this chapter again.